Welcome to the last video, using OpenVPN. In our previous video, we dealt with using OpenSSH as a SOCKS proxy. In this video, we will install OpenVPN on the server and generate a static key, then set up the server configuration and create a client configuration file, and finally, copy the static key to the client and connect the VPN from the client as root. OpenVPN is a full SSL VPN solution that allows you to connect two networks at layer 2 or 3 via a TCP or UDP tunnel. It is available on openvpn.net or via your distribution's package repositories. OpenVPN offers a number of options for authentication. We're going to set up a simple configuration, which will get you up and running. From there are multiple options, which you may want to consider for your needs. Cool, now let's see how to do it. Install OpenVPN on the server with sudo apt-get install OpenVPN for Debian derivatives like Ubuntu, or sudo yum install OpenVPN. Generate a static key using OpenVPN. Set up the server configuration. You can see examples in the USR, share, doc, OpenVPN, examples/sample-config-files. For our purposes, we'll start with server.config and enter this command. Create a client configuration file. Copy the static key to the client via SCP, copy-paste, or another manner. You'll want to make sure that you keep this key secure, as it will now allow access to your network. If your OpenVPN server is not the router for your local network, you'll need to forward port 1194 to your OpenVPN server and define a static route which routes traffic addressed to 10.8.0.2 to your OpenVPN system. Connect the VPN from the client as root. You should now be able to ping any IP on your local network. Now let's see how it works. For authentication purposes, OpenVPN offers the ability to use TLS certificates for both the client and server, or optionally use a single static key. In this case, we're using the static key approach for a fast and easy configuration. This method requires that we share a single key generated by OpenVPN's gen-key command on both ends of the connection. Let's look at the server configuration. To start with, we're specifying that we'll run over the UDP protocol. OpenVPN supports tunneling over both TCP and UDP, but UDP is recommended and is the default. The reason for this is because UDP does not include any retransmission functionality. When transmitting TCP or UDP over a tunnel, an additional layer of fault tolerance below it can cause unnecessary overhead in the event of packet loss where both TCP layers attempt to solve the problem. Next, we will specify the user that the OpenVPN daemon should run as. This is a security precaution which makes sure that in the event of a compromise of the daemon, the user will get access to an unprivileged account rather than root. Next, we specify the secret file. You'll want to provide the complete path to where the file may be found. In our example, we've used the OpenVPN configuration directory used on Ubuntu systems. The ifconfig command is used to specify the tunnel endpoints. The first IP address is the address on the local system that will provide a connection to the second IP, which is the client tunnel endpoint. comp-LZO is an optional configuration option that provides LZO compression for the connection. This utilizes more CPU power in order to compress the network traffic, which may substantially increase your throughput in the event that you're sending highly compressible content like text. If your traffic is mostly already encrypted or compressed or binary, you may see less improvement. In this event, you may decide to disable the option. Finally, verb3 defines the verbosity level for logging purposes. Verb3 is considered medium output and is useful for normal operation. When troubleshooting a problem, you may want to use 9 instead, which is the verbose level. Okay, now we'll look at the client configuration. You'll see the configuration here is very similar. The big difference is that you're specifying a host to connect to via the remote variable. This may be the host name or IP address of your public IP address. The options to ifconfig are also reversed since we're creating the opposite side of the tunnel, so the local versus remote variables changed. We also add a new route variable that will define the IP ranges which are tunneled. Traffic from the client in this case will be routed over the internet as normal, unless the recipient traffic is in the 192.168.1.0 or 24 range, in which case OpenVPN will tunnel the traffic. Now that the configuration file exists, we can launch the OpenVPN client by running sudo openvpn --client openvpn.conf. The sudo is required here, as setting up tunnels requires root privileges. Once the daemon is running, it will drop privileges to the user that you specified in the user variable. Superb! In this video we have dealt with using OpenVPN. Cool, here is the end of the section. In this section we installed OpenSSH, then used OpenSSH as a basic shell client. Next, used OpenSSH to forward defined ports. After that, used OpenSSH as a SOCKS proxy, and finally, used OpenVPN. In the next section, we will see web server. See you soon there.